So hi everyone, I think we should start. It's already 3:04. I think yeah, we are ready to go. So let me welcome you all to the live session 5 for the course Digital Circuits. So this session is basically a problem solving session. Here we'll be solving mostly multiple choice questions pertaining to the week 5 material of the course. I'm your course TA. My name is Musab Rafiq. I'm a PhD student in the Department of Electrical Engineering at IIT Kanpur. This course is taught by Professor Shantanu Chattopadhyay. So, regarding the rules and regulations of the course, so I'll be solving 20 to 21 problems today. After each problem, I'll be giving you some time to asking your doubts. You can ask your doubts using the chat box, or if not, you can unmute yourself and ask the doubts. Apart from that, during the course of the lecture, this live session, I have kept some problems for you guys to solve first. Then after that, I'll show the solutions to those problems as well. So this is week 5. So in this week 5, we'll be discussing this problems related to arithmetic circuits code converters. Mostly it will be based on the implementation of logic functions for using the multiplexers. And also we'll be seeing some problems pertaining to the binary coded decimal, that's the BCD, 841 representation, that's other name for that. And also some problems related to decoders and coders. We'll be looking at those. So just give me a second. I'll just arrange some space for myself. Yeah. So today, let's start with the first problem. That is, so the problem first states that in the following circuit X, so we are given this circuit, and we are required to find the X. Basically, find the output expression for X. So what we have here is we have two. First of all, let me just mark this one. We have two 4:1 mux. I'll just call this 1 and I'll call this mux 2. So we have two 4:1 mux, and we are required to find this X, right? So let's just take mux 1 first, right? We have mux 1. So in general, for a 4:1 mux, my output expression is y equal to S1 S0 complement times I0 plus S1 S S1 bar S0 I1 plus S1 S0 bar I1 plus S1 S0 I2, right? Now here what we have here is we have output Y as it is, and in place of S1 and S2 S0 we have A and B. These S1 and S0 are termed as select lines, right? So these S1 and S0 are termed as select lines. So for a 4:1 mux, we have two select lines. Now just plugging the values we have here is for mux 1, we have y equal to S, in place of S1 I will write A bar, B bar, I0. Then I have A bar, B, I1. Then I have A, B bar, sorry, this is, yeah. Then I have A, B bar, I2. And then I have A, B, I3. This was 2, this was 3, just a small mistake. Now I'll just plug the values of I1 and I0. I0 is 0, so this will be 0. Then I1 is 1, so it will be A bar B. Then I2 is again 1, so it will be A B bar here. This I1 is I2. And finally, this will be 0. So that implies my Y is equal to A bar B plus AB bar, right? Now this output Y is going where? This output Y is going as a select line to mux 2. So what we'll do is we'll write for mux 2 x, that is my output right here. X will be equal to S1 S0 bar I0, again writing the general expression for 4:1 mux, then S1 S0 I1, then S1 S0 bar I2, and finally S1 S0 I3. So X is equal to, what is my S1? My S1 is Y. So it is Y bar and S0 is C bar I0 plus Y bar C I1 plus YC bar I2 plus YC I3. Now plugging the values of I0 and I1, my expression reduces to YC plus YC bar, because I0 and I3 are equal to 0, as I1 and I0 and I3 equal to 0, and I1 and I2 equal to 1. Now plugging the value of Y here. So X equal to A bar B plus AB bar, so A bar B plus AB bar whole bar C plus A bar B plus AB bar times C. So what I will do here is, I simply know that complement of an OR gate, so sorry, exclusive OR gate, that is XOR gate, this expression A bar B plus AB bar represents an XOR gate, and its complement is exclusive NOR gate, so it will be simply AB plus AB bar. So just keeping some steps, by now you should be familiar with these steps as well. So it is AB plus AB bar, this is the expression for exclusion OR gate, times C plus A bar B plus AB bar times C. So it will be then A B C plus A bar B bar C plus A bar B C plus A B bar C. So just wait a second, I'll admit some students first. So ultimately my answer will be, let me just rearrange the term, so it will be A B, so yeah, this is C bar, so it will be A B bar C bar plus A bar B C bar plus A bar B bar C plus A B C. And if you closely look at the options, this is option A. So option A is my correct answer. Any doubts in this question? So let me just repeat for the students who came late. Actually, this is the first question, so I'll make an exception. I'll try to repeat. In case you still have some doubts, you can always ask me at the end. So I'll just give the crux of the solution. We have two mux here, 4:1 mux here. What I did first, we have to find the output X for the following circuit. What I did is, first I took the output of first mux that I have labeled 1, and I written the expression for that here, and plug the values of A, B from the select lines. Basically S1 and S0 are select lines, so which we are applying A and B to, which we are applying A and B. And accordingly, I plugged the values of I0, I1 and I3. So ultimately, I got Y equal to A bar B plus AB bar. Then this Y goes as a select line to mux 2. And for that, I also written the expression, plug the values of I0, I1, I2, I3, and I got X equal to Y bar C plus YC bar. Then plug the values of Y, basically Y is this that I got from here, and ultimately I got my final expression as this. Just a simple, only thing is you need to know this expression for a 4:1 mux, which is quite easy to write. Now I have a question here, which says that in a multiplexer, if there are 4 input lines and 1 output line, then number of selection lines will be. So this is a pretty simple question, but I'll try to write some general formula for it. So we are given 4 input lines, right, and 1 output line, which is quite trivial for a mux. So we have a 4:1 mux, and we need to figure out how many select lines are here. So just simply we saw in the previous question, it will be 2. So the output, should I say, the select lines are 2. But we can write a general expression, right? If I have, let's say, n select lines in a mux, that implies my mux will have 2 raised power n input, so that will be 2 raised power n is to 1 mux. So here what we have here is we have 2 raised power n equal to how much? 4. That implies 2 raised power n is equal to 2 raised to power 2, implies n is equal to 2. Similarly for 8 is to 1 mux, we will have 2 raised power 3 is equal to 8, implying n equal to 3. So for 4 input lines, my select lines are 2, which is the general expression which is here. For n select lines, I have 2 raised power n inputs. Now I have this question here. This is question number 3, which I have marked. By marking, I mean I'll ask you guys to solve it first, and then I'll show the solution. It should not take more than, I think, a couple of minutes or 3 minutes. So the question asks us, a 3 is to 8 decoder is shown in the figure. Find f of x2, x1, x0. So what we have here is we have a 3 is to 8 decoder, and we need to find out the expression for f. So I'll just give you 2 to 3 minutes, and you guys can type in your answer. Just write the correct option only. Then I'll show you the solution also. So far, I have only one answer from a student. I expect others to do as well. Any other answer? Only two of the students have solved it so far. Anyways, nice try. So let me just show the solution. So we have the output f, right? So for f, we can simply write d1 plus d4 plus d7 whole complement, right? This is what we can write because it is a NOR gate. Then what we can do is we can write f is equal to, it will be d1 complement dot d4 complement dot d7 complement. So what will be d1? So d1 will simply be a bar b bar c whole complement dot a b bar c bar complement dot a b c whole bar, right? And then using the De Morgan's law, I'll have a bar, sorry, a bar bar. So I can write a bar bar, b bar bar, c bar, and here it is plus. Then a bar plus b bar bar plus c bar bar, and it will be a bar plus b bar plus c bar, right? So f will be equal to a plus b plus c bar, a plus b, a bar plus b plus c, and this will be equal to a bar plus b bar plus c bar. So this will be equal to product of max term. So this is what term is this? This is 1, this is 4, and this is 7. So this is product of max terms 1, 4, 7. And in terms of sum of min terms, it will be 0, 2, 3, 5, 6, right? And this right here is my answer, and that is option B. Any doubts? If there are any doubts, you can use your chat box. If you're not comfortable with the chat box, you can always unmute yourself and ask the doubt. I think so far so good. Let's go to the question number 4 of today's live session. We have a 2:1 mux where the inputs are A1, A2, A3, where A1 goes to my select line, and A2 and A2 and A3 go to some logic gates, and then towards the input of a 2:1 mux. So we need to find out this F, right? So what we have here is we have A2 and A3 going to an AND gate first. So this is AND and going to an OR gate. And we have one stack line. So since it is a 2 cross 1 mux, we only have one stack line. So let's just mark the inputs first. So I0, what will be I0 equal to? I0 will simply be equal to A2 dot A3. That is the AND operation between input A2 and input A3. Then we have I1. What will I1 be equal to? It will be an OR operation between A2 and A3, right? And finally, my F will be equal to S times S bar times I0 plus S times I1. So this is S, right? Select line. So F will be equal to A1 bar I0 plus A1 I1. And what is A1? A1 is A1. So what is I0? We found out here. So it is A2 dot A3 plus A1 A2 plus A3, plugging the value of I1 here, right? Then we have A1 bar A2 A3, right? Plus A1 A2 plus A1 A3, right? Now looking at the expression, I think I can simplify it further. So what I'll do here is I'll take A2 common out of the first two terms. So what I'm left with is A1 bar A3 plus A1 plus A1 A3. So what is this equal to? Anyone? Anyone in the chat box? What is this equal to? Correct. This is equal to a1 plus a3. Basically, this is of the form a plus b bar c. So a plus b, sorry, a plus a bar c, a bar b. So that is equal to a plus b, right? So this is equal to a2, a1 plus a3 plus a1, a3, and ultimately I'm left with is a1, a2 plus a2, a3 plus a1, a3, and this is option A, right? Yeah, this is option A. So option A is your correct answer. Any doubts in this question? If not, then we can proceed to question number. This was 4. Now question number 5 for today's live session, which says that addition of 96 and 69 in BCDs, so binary coded decimal. Is it binary coded decimal? Yeah, I think it's binary coded decimal. Is so we need to find out the addition of 96 plus 69 in BCD, right? So first we will write 96 in BCD. So taking the 9 first, so 9 can be written as 1001 and 6 is written as 0110. Then 69 in BCD will be, so first 6, so it will be 0110 and 9 will be 1001. So let me write these two numbers here first, and we'll do the addition to it. So this will be 1, 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 this will be 1. So, question to you guys: are these the legal addition terms in the BCD addition? So, since they are not, what do we have to add to them? Yes, 0110. That is basically 6. So 0110. So let me just highlight this and this ill to mark them as illegal. So 0110. So ultimately I'll have, so this will be 1. This will be 1 plus 1 is 01. 1 plus 1 is 1. So this 1 plus 1 is carry. 1 plus 1 is 0, 1. So 1 plus 1 is 0, 1. 1, 1, 0, 1. So it is 1, 0, 1, 1, 0, 0, 1, 0, 1. That is option C. Any doubts in this question? If not, let me just go to the next question. This question I have kept as an exercise for you guys to do first. I'll just show the solution afterwards. So the question states that the logic function implemented by the multiplexer circuit where ground implies logic 0 is, so you need to find out the logic function implemented by the following circuit. It should not take more than 2 minutes. So please type in your answer, only the correct option. Afterwards, I'll show you the solution. So I see some answers in the chat box. That's quite nice. I think this was a pretty straightforward question for you guys. So let me just show the solution. So before we proceed, let's just figure out what are the inputs. So this right here, what is this? This represents a ground, and ground represents our logic level 0. So this is 0, so that implies I3 is 0. This is 1, and this signal is going to I1 and I2, and this is 0, right? So that implies from the circuit I have I0 equal to I3 equal to 0, I1 equal to I2 equal to 1, right? Now my select lines S1 is equal to P and S0 is equal to Q. Two select lines with two variables P and Q. So what I have here is F is equal to S1 S0 I0 plus S1 S0 I1 plus S1 S0 bar I2 plus S1 S0 I3. Now plugging the values, so this will be I0 0 plus P bar Q dot 1 plus PQ bar dot 1 plus 0. So F is equal to P bar Q plus PQ bar. So you have seen this expression again and again. This represents the what should I call, P XOR Q, or you can write it like this, P XOR Q. That is option D, right? So most of you, I can see, have written the correct, almost all of you have written the correct answer, and that's nice. So any doubts in here? If not, we can proceed to question number 7 of today's live session, which states that so this was 6, right? Yeah, I thought I messed up with the numbering. Yeah, so this is question number 7 of today's live session. It states that how many 2 is to 4 decoders are required to implement 4 is to 16 decoder, right? So we need to find out the number of 4 is to 2 is to 4 decoders that can be used to make a 4 is to 16 decoder. Here we are assuming we don't need any logic gates, only using decoders. So before going to the particular question, let me just show you the how it's generally done. So if I have an M1 cross N1 decoder that is given, and I need to implement, this is given, and I need to implement using this M2 cross N2, right? So required. So what I'll have here is I'll add N2 and divided by N1. I'll get a quotient out of it, that is K1. Then I will divide this K1 by N1. I'll get K2. Then this K2 by N1. I'll, I'll get K3. So on, unless I'll get 1 here. And my number of decoders required will be summation of ki's, right? So using this general rule of thumb, what we have here is we have 4 is to 16 decoder. So here n1 is equal to 4 and n2 is equal to 16. So n2 by n1 will be 16 by 4, that is 4. So this is my k1. Then 4 by 4 is 1, and this is my k2. So my number of decoders required will be number of decoders, and here I should write 2 is to 4 decoders required to implement 4 is to 16 will be 4 plus 1, that is summation of ki's, that is 5. I see some of the students have written 4. I hope the doubt got cleared. Now here I want to show you one thing. How it's done. Just give me a second. Just a second. Sorry about that. Yeah. So I'll repeat. So what I have here is for a general M1 cross N1 decoder that is given to us, M1 cross N1 decoder that is given, and we are required to implement M2 cross N2 using this M1 cross N1, right? So M1 cross N1. So here M1 and N1 are 2 cross 4 and M2 and N2 are 4 cross 16. So how will we find that how many decoders are required to implement the 4:16 decoder or any given decoder? So what we have here is we'll take this N2 here and divide it by N1. So what I will get here is K1, that is my quotient, and then this K1 I will divide it by N1, right? So I'll get K2, so on up to unless I'll get my quotient as 1, and then so this one will be Kn. So then some of these KIs will give me the number of decoders that are required to implement a given decoder. So what I have here is I have 4:16 decoder that is needed to be implemented by 2:4 decoder, 2 cross 4 decoder. So my N1 is 4 and my N2 is 16. So I'll divide this 16 by 4. I'll have 4. That is my K1. And then I'll divide this K1 4 by 4 because my N1 is 4. I'll get 1. And my K1 plus K2 is 4 plus 1, that is 5. So my required answer is 5. I'll show you also how it is 5. So here I have 2 cross 4 decoder having enable E, and here are inputs A and B. So output will be 4. Here this again 2 cross 4 CD, 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 and also CD. This goes here as the enable, this goes here as the enable, goes as the enable, and ultimately this goes here as enable. This will be your Y0. Oops. Right, so this is Y0, Y1, Y2, Y3, this is Y4, so on up to this will be Y15. And this complete block is your 4:16 decoder. Got it? Any doubts? So no doubts. Then I think we can proceed to this was question number 7. Question number 8 of today's live session. So what we have here is we have to find the accessory code of decimal numbers 24 and 658. So accessory code of 24 will be, let's just say 24 and write the BCD of it. So it will be 0010 and 10100. Add 3 to individual numbers. So this will be 0011 0011. This will be 11101. So this is the XS3 code of 24. Basically adding 3 to the number, and part B, that is 658, I'll have here is 0110 0101 1000. So adding 3 to all individual bits, I mean to say individual BCD numbers. So I'll have here is What I have here is 1 1 0 1 0 0 0 1 0 0 1 excess 3 of 658. Right. Another way of doing here is what we can do is, okay, yeah, this is simple. Just write the BCD of the number and then add 3 to the each BCD number right here. This is pretty straightforward. Now, I have a question here which states that, let me just see what is the exact question I have here. Yeah, so it states that implement the Boolean function. Yeah, implement the Boolean expression f of a b c equal to sum of minterms 2 3 6 7 using a multiplexer. So I kept it general. I have not given which multiplexer you wish to use. I just want to use some idea here. So there are two ways of implementing a basically we can use two types of multiplexers to implement a given function. So if we have n variables, right? If we have n variables, just a second. If there are n variables, I can use 2 raised power n is to 1 mux to implement the function f, right? I can use 2 raised power 1 is to 1 mux to implement the 2 raised power n is to 1 mux to implement the function. And in this case, my all variables are applied at select line, right? Select lines. And also I can use, and depending upon the function, inputs are then applied to I0, I1, I2, 0 or 1, depending upon the functionality. Also I can use 2 raised per n minus 1 is to 1 mux, right, to implement a function. And in this case, n minus 1 variables go to the select line and one variable is applied at the input of the mux, right? So for this question, f of a, b, c equal to sum of minterms 2, 3, 6, 7. Just to get start with, I'll just assume I have 8 is to 1 mux to implement this function. So simply, this is A, this is B, this is C, this is S2, S1, S0, this is 8 is to 1, this is my I0, I1, I2, I3, I4, I5, I6, and this right I7 here. So based on the functionality here, I0 will be 0, I1 will be 0, I2 will be 1, I3 will be 1, I4 will be 0, I5 will be 0, I6 will be 1, and I7 will be 1. So this block that you see here will implement f of a, b, c equal to sum of minterms 2, 3, 6, 7. Right? Any doubts in this question? Not, then I can go to question number 10. So this question I kept to you guys. So I'll just write some conditions for you first. So implement the Boolean expression f of a, b, c, sum of minterms 0 to 5, 6. So it's again a three variable function, but I'm asking you guys to implement it with 4 to 1 mux. And also use b and c as select lines and a as your input to the mux. How you will write your answer? You write like I0 equal to I1 equal to I3 equal to and I3 equal to, right? So basically, if your answer is 0110, 0110, you can write 0110, or let's say 011A, you can write 011A as your answer, right? So do this, it should not take more than 3 minutes or 4 minutes. Then I'll show the solution. So let me repeat the question. Implement the Boolean expression f of a, b, c equal to sum of minterms 0 to 5, 6 using a 4:1 mux. Keep b and c as your select lines, a as the input to the multiplexer. And you can write your answers as the inputs I0, I1, I2, I3. Anyone with the answer? Or you guys are still doing it? So answer you can write like this: I0, I1, I2, I3. Values of each input. This is a pretty straightforward question, or you guys are seeing it for the first time. Anyone? Anyone with the answer? Is the question clear? Uh, so I think I was expecting at least a couple of answers. Anyways, let me just show the solution. So what I have here is I have three variables A, B, and C, and I have 4 is to 1 mux to implement function 0, 2, 5, 6. So that implies my B and C are the select lines, and A will be applied to the inputs of the mux depending upon the functionality that I have to perform. So this is my 4 is to 1 mux, this is my B, this is my C, this is S1, S0, this is I0, I1, I2, and I3. Now I'll draw this table to find the values of I0 and I1. This is A bar, this is A. This will be I0, this will be I1, this will be I2, this will be I3. Then I'll write 0, 1, 2, 3, 4, 5, 6, 7. Just one question here. Does anyone know what's this table called? What do we call this table? I think it has a proper name. What is this table called? Am I audible? Just to be sure, actually, I'm not getting any response. Yeah. So what is this table called? It has a proper name to it. So let me just tell you, this is called implementation table, right? And above I written I0, I1, I2, I3, so that represents my input to the mux. So now what I'll do here is I have sum of minterms 0, 2, 5, 6. I will encircle all those minterms that are in the function. So I'll encircle 0, I'll encircle 2, I'll encircle 5, and I'll encircle 6. Now I'll take a look at I0. So in I0 only 0 is encircled and 4 is not encircled, and 0 corresponds to A bar, so I'll write A bar here. In I1 column 5 is encircled and it corresponds to A. In I2 column both are encircled, that means it is a 1, and in I3 column none of the terms in encircled, so it means 0. So what I have here is I have A that goes to an inverter, I'll have A bar that will go to my I0, A will go to I1, I2 is 1 and I3 is 0, right? So that implies I0, I1, I2, I3 is equal to 0, 1, A bar. So this is how you implement a function ABC equal to sum of minterms 0 to 5, 6 using the 4 is to 1 mux. Any doubts in this question? Have you seen these type of questions? Let me just uh, ask you this. Strange. Was this not taught in the material, in the week 5 material? I think it is taught, as far as I know. So, okay, anyways, did you understand how we arrived at the answer? Did you get the logic behind it? Okay, thank you. Now I have another question for you guys to solve first, then I'll show the solution. So the question asks us find the number of mux required to implement 16 is to 1 mux. Basically, how many 2 is to 1 mux are required to implement 16 is to 1 mux? So do it. So yeah, now let me just show the solution. I think some of you have written the correct answer. So again, let me just show the first the general way to approach the problem. So we have, let's say we have a mux that is m cross 1. This is the required one, and given here is n cross 1. So this is given. What I'll do is I'll take m divided by n, I'll get a k1, then I'll divide k1 by n, I'll get a k2, so on up to k n minus 1 by n, I'll get a 1, which is a kn, and my number of muxes will be required will be equal to summation of ki's. As we saw in the decoders, kind of a similar approach we have taken here. So we have m equal to 16 and n equal to 2. So what I have here is 16 divided by 2, that is 8. Then 8 divided by 2, that is 4. 4 divided by 2, that is 2. And 2 divided by 2, that is 1. So this is 8 plus 4 plus 2 was 1. So this is 15. Option A is the right answer. As some of you, almost yeah, couple of students have done the correct answer. Right. Now I have with me this question. Consider the circuit shown in figure and you need to find out f, right? This is as simple as it is. So what is this? What is this? Anyone? What is the block that is shown here? Yeah, mux, correct. But what kind of mux? Yeah, yeah, 2:1 mux, right? So this is a 2:1 mux. Let's term this here as let's just call it as y1 or maybe some other term. Let's call it a w, right? So my w will be equal to si0 plus si1. S is x, so x bar, I0 plus x, I1. I0 is y, so it is x bar y, and 1 is 0, so it will be 0, x bar y only. This x bar y, that is w, goes to this, and its complement goes to this, so that is w bar. So my f is equal to s bar I0 plus si1, and that is equal to s bar is z bar I0 plus zi1, because select line is z. Z bar I0 is W, and I0 is W, and I1 is W bar here. So this is Z bar. W will be equal to X bar Y plus Z times X bar Y whole bar. So it is X bar Y Z bar plus X bar bar plus Y bar times Z. So it is X bar Y Z bar plus X plus Y bar Z. So it's X bar Y Z bar plus XZ plus y bar z, x bar y z bar plus xz plus y bar z. So option B is the correct answer, right? So this was an easy question. I think most of you have done it at your place as well. So now I have a question for you guys. This is if you understood this question. So I was of the impression that you know how to solve a question where you have, let's say, n variable system, and you are given only n to raised power n minus 1 is to 1 mux to implement it. That is basically if you have three variables function, you need to implement it a 4 is to 1 mux. Like here you have a 4 variable function and you have to implement it using a 8 is to 1 mux. So for this it will require something along this methodology will be along these lines, right? So concept is along these lines. So I hope you guys can solve it. So the question is, I'll show the solution, don't worry, but I want you guys to try it. So the question is f of a b c d equal to sum of minterms 0 1 5 6 8 10 12 15, right? And you are given the 8 is to 1 mux. So what you will have here is your b c d will be going to the select lines, and your a will be going to the input of 8 is to 1 mux. How will you write your answer? You write your answer like this: I0, I1, I2, I3, I4, I5, I6, I7. So write your answer like this with their corresponding values. So you have to implement this function using 8 is to 1 mux with BCD as your select lines and A as your input. Can you do it? I have shown it how to do it for with three variable system. I think applying that logic you will be able to do it. Any question? Somebody raised a hand. Any doubt? Just one more minute. One of the students has written some answer. Let's see whether that is correct or not. Anyone else? Okay, I have at least a couple of answers. So what we have here is we have a f of a, b, c, d, four variables. Three of them are my select lines. One input a is my input to mux. F of a, b, c, d is sum of minterms 0, 1, 5, 6, 8, 10, 12 and 15, right? So let's just draw 8 is to 1 mux, S2, S1, S0. This is B, this is C, this is D, this is I0, this is I1, this is I2, I3, I4, I5, I6, I7, and that is termed as this will be your F, right? Let's just draw this table which I told you is called implementation table. This is A bar, this is A, this is I0, I1, I2, I3, I4, I5, I6, and this will be I7, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the terms that are there in function, the minterms, what I have to do with them, I'll encircle them, right? As I told you, I'll encircle all those terms that are in the function. So 0, 1, 5, 6, 8, 10, 12, 15, right? Now in I0 column, my both are encircled, so I'll write 1. In I1 column, only A bar is encircled. In I2, only A. In I3, none of them, so it will be 0. In I4, A. In I5, A bar. In I6, A bar. And in I7, A. Right? So this is my answer, as some of you have written. So this will be 1, this will be A bar, this will be A, this will be 0, this will be A, this will be A bar, this will be A bar, and this will be A. So this complete thing will implement the function that was given, right? Now my question answer is how many 3 to 8 line decoders with enable output are needed to construct a 6 to 64 line decoder without using any other logic gate. So we saw it earlier as well how we approach to these problems. What we'll do here is we'll take 64. So I told you this n1 so m1 cross n1, and we have to implement m1 2 cross n2. So we'll do is n2 by n1 will get k1, then we have k1 by n1 will get k2, so on up to kn, which will be 1, and summation of ki's will give me number of this. So 64 by 8 will be 8, 8 by 8 will be 1, and 8 plus 1 is 9, as rightly written by one of the student. Option C is the correct answer. Now, the number of select lines required in 1 is to n demuxes. So we are given a demux 1 is to n, and we need to find out how many select lines will be required. So when we have, let's just say in general, when we have m select lines in a demux, my output will be 2 raised to power m. So that implies n is equal to 2 raised to power m, and that implies m is equal to log to the base 2 n. So my select lines will be log n, and it's to the base 2. Option C. Now I have this question for you guys. Please do it at your place and then write this answer in the chat box. So the question asks us, find the BCD equivalent of 345, where 345 is the decimal number and you need to find its BCD equivalent. Do it. And let me just take a couple of minutes break and then we can resume. Oh, nice. I see. Most of you have written the option and indeed the right option. So it's 3, 4, 5. So 5 is written as 0, 1, 0, 1. 4 is simply, basically I'm writing this BCD equivalent. 4 is 0, 1, 0, 0. 3 is 0, 0, 1, 1. So the BCD equivalent will be equal to 0, 0, 1, 1, 0, 1, 0, 0, 0, 1. So option D, as most of you have written, is the correct option. And again, I have this question. The number 762 would be represented in 8421 code or BCD code as. So 762, I need to write its BCD equivalent. So let's just write for 7. So 7 will be equal to 0, 1, 1, 1. 6 will be 0, 1, 1, 0. 2 will be 0, 0, 1, 0. So it will be 0, 1, 1, 1, 0, 1, 1, 1, 0, 0, 0, 1, 0. So option, which is the correct option? C. Option C is the correct option. Now I have this question. I would like you guys to solve it first. So the question states that consider the output A and B with I0, I1, I2 and I3 as input and A and B as output. So the above circuit is, so you are given four inputs and output as A and B, and the relation between input and output is A equal to I2 plus I3, B equal to I2 bar I1 plus I3, and you need to find out what is the functionality of above circuit. Do it. What is the correct answer? Yes. Thank you. So option is D. That is the priority encoder. So how? Let us see the truth table of priority encoder. So this is here right here is truth table of priority encoder. So when I0 is 0, when I0 is 1 and all other inputs are 0, my output will be 0 0. And when I1 is 1, my output will be regardless of the I0 value, my output will be 0 1. And then when I2 is 2, regardless of the value of I1 I0, my output will be 1 0, that is 2. And when my I3 is 1, whatever will be the value of I2 I1 I0, my output will be I1 that is 3. So this is the priority encoder. You can construct a Corno map for this, and you can write and you can see the output A and B will come out to be like this. And also looking at this output, you can see this A equal to I2 plus I3. So whenever I3 is 1, my A is 1 and B is 1 from this. So that means for I3 equal to 1, A and B are equal to 1. And if you put I3 equal to 0 and check for condition for I2, you'll again have this I3 equal to 0, and when I2 equal to 1, my A and B will be equal to A will be equal to 1, B will be equal to 0. So this is the priority encoder operation. So even if you have seen this priority encoder truth table, you would have easily guessed it that this is the functionality of a priority encoder, right? Now I have question 19. So can anyone tell me what is the functionality performed by the combinational circuit that is given in the figure? Let me just increase the size. So what is it? Yes, it is a 4:1 mux. Simply you can see like you require if you have 4:1 mux and you have to implement using 2:1, you will have 4 by 2 that is 2 and 2 by 2 that is 1, and you need total 3 2:1 mux 1 2 and 3, and you'll have 4:1 mux. For all other options, you need much more 2:1 muxes to implement that. So option A is correct answer. And also you can write a complete set of equations, and from that you will have ultimately y is equal to s0 s1 bar I 0 plus s1 s0 I1 plus s1 s0 bar I2 plus s1 s0 I3. If you solve this, you will get this expression. But you can easily rule out without solving just by looking at it. You know, 3 2:1 mux will be required to implement 1 4:1 mux, and also for all other options, much more muxes will be required. So for 8, you will have 8 by 2 that is 4, 4 by 2 that is 2, 2 by 2 that is 1. So you need 7. So you could have easily written outrightly it's a 4:1 mux, right? Rather than solving it completely, just by looking it and by from your memory, you can easily write this. So I want you guys to solve this question first. So let me just remove these. There are some lines here. So give me a second. Yeah. So this is a question I would like you guys to have a look at first, and then I'll show the solution. So the question asks us what should be the value of D0, D1, so on up to D7, so that the minimized output F equal to A times B plus C. So you need to give me the values of d0, d1, d2, so on, such that the value of the function will be equal to minimize output of f of equal to a f is equal to a times b plus c. So what will be the values of d0 up to d7? And here are your options at the bottom. Anyone? Has anyone done it? Has any student done it, or are you guys still doing it? Okay, let me make a life a bit easier for you. So in place of this, I'll have this. Now, can you do it? Yes, yes, that's the correct answer. So the issue was just identifying what is this whole block. So you are using 7 2 is to 1 mux, and ultimately you'll get a 1 8 is to 1 mux. Depending on the conditions I were given, it was a 8 is to 1 mux. Sometimes you may not be aware that it is a 8 is to 1 mux. So what will you do? You'll just evaluate the complete function. Not a big deal. What happened? Yeah, just keeps on crashing and crashing. So, what I was saying is sometimes you may not be able to decode it that it was a 8 to 1 marks. So, at that time, what will you do? Just simply evaluate it. So, just term this as x1, this as x2, this as x3, and this as x4, this as x5, and this as x6, right? So, let's just write expressions for each of them. So, x1 will be equal to c bar d0 plus cd, x2 will be equal to c bar d2 plus cd3, x3 will be equal to c bar d4 plus c d5, and x6 will be equal to c bar d6 plus c d7, right? Now my x5 will be equal to b bar x1 plus bx2, so that is equal to b bar c bar d0 plus c d1, basically writing the x1, plus b times c bar d2 plus c d3, right? So ultimately my x5 will be equal to b bar c bar d0 plus b bar c d1 plus b c bar d2 plus b c d3. Similarly, x6 will be equal to b bar c bar d4 plus b bar c d5 plus b bar c d6 plus b c d7. And this f of ABC will be equal to a bar x5 plus a bar x a bar a bar x5 plus a x6, and if you evaluate this, f of a b c will be equal to a bar b bar c bar d0 plus a bar b bar c d1, so on up to a b c d7, and this is your 8 is to 1 mux. Now my function that I had was required to implement was f is equal to a times b plus c. You can write it as ab plus ac. You can write it as ab times c plus c bar plus ac times b plus b bar. And when you evaluate it, it gets reduced to a b c plus a b c bar plus a b c plus a b c bar. So A B bar C, sorry, A B bar C. So ultimately it is sum of min terms 5, 6, and 7. A B C, right? 5, 6, 7, A B. Yeah, it's sum of min terms 5, 6, 7. So for 5, 6, 7, you need 1, 1, 1, and all other terms to be 0. So that is option D, right? I hope this was clear, right? Basically, the question was if I have to reduce everything I have to reduce. Ultimately, the question was f is equal to sum of min terms 5, 6, and 7. F of ABC, let me just write f of ABC is equal to sum of min terms 5, 6, 7, and you had to implement it using 8 is to 1 mux, right? This was the question, nothing more, nothing less. And in that case, you needed to apply 1, 1, 1 signal at 5, 6, 7. So if you were able to visualize this problem within a 10-20 seconds, entire problem would have been solved in 20 to 30 seconds, right? And now I have the last question for today's live session. It states that determine the inputs of given 4 is to 1 mux to have the output Q is equal to xy plus z, where x is your MSB and z is your LSB. Use x and y as your select lines. So MSB and the second bit towards the right of the MSB as select lines, and z LSB as your input variable, right? So Q is equal to xy plus z. Let's first just determine what we have to implement. So it will be xy z plus z bar plus y bar z. So Q will be equal to xyz plus xyz bar plus yz plus y bar z. Q will be equal to xyz plus xyz bar plus x bar yz plus x bar y bar z. Q will be equal to x plus y plus z, x plus y plus z bar plus xyz plus x bar yz plus x y bar z plus x bar y bar z. So Q will be equal to this, writing the terms x bar y bar z plus x bar y z plus x y z bar x y z bar plus x y z. So Q will be equal to sum of min terms 1, 3, 5, 6, 7. And now I have to implement this using 4 is to 1 mux, where x and y are my select lines, x and y are my select lines, z is my input variable, and z is my LSB. So I have here 4 is to 1 mux. Here I have a, so it is x y z. So I should write here x and here. Now question to you guys. Now what I have to do? What table I have to draw? What is the name of the table that I have to draw? Yes, implementation table. What should I write here? Here, what should I write here? Just for the revision purpose, what should I write here? Z bar and Z, correct. 0. What should I write here? What should I, sorry about that. What should I write here in the question mark? What should I write here? Anyone? I see someone has written 1. Is 1 correct? Should I write 1 here? I'm not getting any response, but in this case, I'll write 1 here, and 2 here, 3 here, 4 here, 5 here, 6 here, 7 here. Can anybody tell me why? Why I written it like this? Why I have written it like this? Where I have written 0 first, and in the next, in that column only I have written 1. Previously, if I just check, I have written it like this, or let me just, I have written it like this, right? What is that is different from the previous question? Correct, correct. Basically, here we are applying the input variable as LSB, right? Previously, our MSB was our input variable. So, as rightly pointed out by one of the students, LSB alternates from 0, 1, 0, 1. That's why I've written it like this. Now, rest of the things will remain same. I will encircle all the minterms 0, 1, 3, 5, 6, 7. This will be Z, this will be Z, this will be Z, and this will be 1. So option A is my correct answer. So that was all for today's live session. Any doubts? Please let me know. If not, we can close this live session and we'll meet next week. That is 1st of September, right? Yeah, 1st of September, Sunday from 3 p.m. to 5 p.m. And we'll be discussing more problems related to this mux, demux, and we'll also be discussing problems related to the flip flops. So from 3 p.m. to 5 p.m. next week. Mm-hmm. Mm-hmm. For that, you have to use it like this, right? Construct a table like this and apply inputs accordingly. Got it? So this entire block is your 8 is to 1 mux, and these are your input. Other than that, all of the things will remain same. Here will be your select lines. These will be your input variables. Got it? So any other question, query? If not, we can close the session. Okay, thank you guys for joining. Thank you. See you again.